Now that we are very comfortable with parallelograms and we know the different properties and different attributes of a parallelogram, those 5 things we talked about before, now we can basically flip them all around and look at the converses, and that's going to give us a way to prove a quadrilateral is a parallelogram. So notice the sentence starter this time. We're not saying if we have a parallelogram, then we know these things, but we're saying a quadrilateral is a parallelogram if certain things are true. So remember, by definition, a parallelogram has 2 pairs of parallel sides. So then we can reverse that and say, well, if a quadrilateral has 2 pairs of parallel sides, then it must be a parallelogram. So that's our first condition for a parallelogram. All right, so let's take a look at this quadrilateral that I drew here, this ABCD. So remember, for this ABCD to actually be a parallelogram, don't just assume it looks like a parallelogram, so therefore it is a parallelogram. But for us to actually conclude it's a parallelogram, we would have to know that the opposite sides are parallel. So AB needs to be parallel to CD, and BC needs to be parallel to AD. If we know that, then we can conclude that ABCD is a parallelogram, right? So again, these parallel pairs of opposite sides tell us it's a parallelogram, okay? So again, we can flip everything else that we had discussed earlier. So the next thing we can say is, well, if a quadrilateral has opposite sides that are congruent, then it is a parallelogram. All right, so again, opposite sides need to be congruent, and that means both pairs. So something I didn't mention earlier is your conditions for a parallelogram are always going to be 2 things. So notice we have 2 pairs of parallel sides. We need 2 pairs of congruent opposite sides. So again, if we are given, or if we know that AB is congruent to CD and BC is congruent to AD, then we can say ABCD is a parallelogram. So again, you have to know 2 things, right? So these 2 pairs of opposite sides are congruent. All right. Next up, same thing as before, right? We knew if we have a parallelogram, opposite angles are congruent. So conversely, if both pairs of opposite angles are congruent, then we know a quadrilateral is a parallelogram. All right, so if we have this parallelogram ABCD, or sorry, my bad, quadrilateral, we don't know it's a parallelogram yet. So if we have this quadrilateral ABCD, how do we know it's a parallelogram? Well, if we know that the opposite angles are congruent, so angle A is congruent to angle C, and angle B is congruent to angle D, then we can say ABCD is a parallelogram. Right? So again, opposite angles, both pairs. Remember, you always need 2 things to prove this parallelogram. All right? Okay, next thing, again, thinking back to what we looked at before, if we know we've got consecutive angles that are supplementary, that'll also tell us we've got a parallelogram. And just like before, we need to know 2 things. So we don't need to know that all the consecutive angles are supplementary, but we just need to know that an angle is supplementary to both of its consecutive angles. So what does that mean? That means, for example, if we are given that angle A and angle B are supplementary, and angle A and angle D are supplementary, then we can say that ABCD is a parallelogram. And what this shows us here is that angle A is supplementary to both of its consecutive angles. So see how A and B are right next to each other and A and D are right next to each other? That means D and B are the 2 angles that are consecutive to angle A, right? So if we know that A is supplementary to both B and D, it's a parallelogram. Same thing, like if we knew that angle D was supplementary to both angle C and A, then we would have a parallelogram. So again, just 1 angle and both of its consecutive angles need to be supplementary. Okay? So next up, remember we had that property that involved diagonals. So if we know diagonals bisect each other, then we have a parallelogram. Right? Remember, bisect means to cut in half. So how do I know if it's being bisected? Well, remember, if we know that BD cuts AC into 2 congruent pieces, and AC does the same thing to BD, then we've got the bisector, right? So basically, if I know that, let's call this middle point E. If I know that AE is congruent to CE, and remember always two things, BE is congruent to DE, then we can say ABCD is a parallelogram. All right? We've got one more that kind of combines two of our properties. So this last one says if we know one pair of sides are both congruent and parallel, then we've got a parallelogram. All right, so again, two things, but this time we're looking at two properties of one pair of sides. So for example, if we know that AB is parallel to CD and AB is also congruent to CD, then we can say ABCD is a parallelogram. So again, one pair of sides need to be not only parallel, oops, wrong one, AB, so for example, one pair of sides again, both parallel and congruent. So it's still two things, right? Then we've got a parallelogram. So these are things you want to think about and remember as we deal with trying to prove a quadrilateral is a parallelogram. So if you look at example 1, that's what I'm asking you to do here. Show me that JKLM is a parallelogram when A is 3 and B is 9. How do I do that? Well, notice this is all talking, this information is all about sides. So how would I know if we have a parallelogram just given information about sides? Well, remember, if opposite sides are both congruent, then we've got a parallelogram. So why don't we show that? So let's go ahead and work out the different side lengths. Alright, so I worked all those out for you, so you don't have to watch me write all that. But basically just plugging in A equals 3 and B equals 9 into each side. And what we can see here is since JK is equal to LM, that means they are also congruent, right? By your definition of congruent segments. Same deal here, right? 51 and 51, that means KL is equal to JM. And again, by your definition of congruent segments, they are congruent. So since the opposite sides are congruent, JKLM is a parallelogram. So make sure you summarize that for me. Tell me what your work represents. All right, so let's take a look at example 2. So now determine if we have a parallelogram. So think back to those different reasons we had for parallelograms, right? So if you look at example 2a, I've got angles. So we know two things about angles that would prove we have a parallelogram. One, if both pairs of opposite sides are congruent, we've got a parallelogram. And two, if one angle is supplementary to both its consecutive angles, then we've got a parallelogram. So you really want to think about which reason would work here. So here I've got one pair of opposite sides that are congruent, but another pair that I don't know. Don't assume information about this unknown side, okay? We don't know it's a parallelogram, so we can't just say I can do 180 minus 107. All right? So let's take a look at the 73. Notice we've got two consecutive angles that are right next to that 73. So just check, right? Are those consecutive angles supplementary? Well, 73 plus 107 does add up to 180. So that checks. So yes, it's a parallelogram, right? Because one consecutive angle is supplementary to both. One angle is supplementary to both its consecutive angles, right? Take a look at B. What can we say about this one? Yes or no? Remember, once again, we're given information about angles. And here I've only got one pair of opposite angles, but I need to know both pairs of opposite angles are congruent. So no, there's not enough information. We can't say that's a parallelogram. All right? So here, again, when it says justify your answer, we want to add in the because. So let me go back and add that in right here. All right, so again, 73 is supplementary to both its consecutive angles, so yes, it's a parallelogram. No, because we need to know both pairs of opposite angles are congruent.